You know what happens when an astrophysicist who spent decades watching NASA push the boundaries of human space exploration watches the media transform incremental progress into revolutionary headlines. You get frustrated not because you don't appreciate the progress, but because you understand the difference between doing something new and doing something that's already been done just more efficiently. Let me be clear from the start. I have tremendous respect for what SpaceX has accomplished. Elon Musk and his team have revolutionized rocket engineering in ways that absolutely deserve recognition. But when I hear headlines screaming that private enterprise is leading us into space because SpaceX is taking cargo to the International Space Station, I have to ask, leading us where exactly? NASA has been taking cargo to space stations since the 1970s. We've been putting humans in orbit since 1962 when John Glenn became the first American to orbit Earth. We've been to the moon 6 times. We've sent robotic missions to every planet in the solar system and beyond. We've been operating continuously in space for over 6 decades. So when SpaceX accomplishes the impressive feat of delivering supplies to the space station, that's absolutely worth celebrating for the engineering achievement it represents. But describing it as opening a new frontier is like saying someone has pioneered aviation because they built a more fuel-efficient airplane. Here's what I think gets lost in all the excitement about private space companies. There's a fundamental difference between doing something that's never been done before and doing something that's been done before, but cheaper and more efficiently. SpaceX has absolutely mastered the second category. Their reusable rocket technology is genuinely revolutionary. When that Falcon Heavy first stage lands back on Earth, ready to be used again, that's engineering poetry in motion. It's the difference between flying to Europe in a Boeing 747 and then pushing the entire airplane off a cliff afterward versus landing it safely and using it for the next flight. Reusability matters enormously for making space access affordable. It's a game-changing innovation that will benefit everyone who wants to use space for commercial, scientific, or exploratory purposes. But innovation and efficiency isn't the same thing as pushing into unexplored territory. And if we're going to be honest about the history of human civilization, truly expensive, truly risky ventures into unknown territory have almost always been initiated by nations, not private companies. Think about it. Who built the Great Wall of China? Not a private construction company hoping to make a profit. Who funded the European cathedrals that took centuries to complete? Religious institutions willing to invest in projects that wouldn't show returns for generations. Who paid for the Manhattan Project, the Apollo program, massive government initiatives driven by geopolitical necessity, not return on investment calculations? This isn't because governments are inherently better at innovation. It's because they can absorb risks and costs that would bankrupt private companies. They can fund projects where the benefits are measured in national security, scientific knowledge, or human achievement rather than quarterly profits. Now, let me paint you a picture of how this actually works in the real world. Imagine Elon walks into a venture capital meeting tomorrow and says, "I want to send astronauts to Mars. It's going to cost maybe $1 trillion. Yes, it's extremely dangerous. People will probably die. And no, I can't give you a clear return on investment." How long do you think that meeting lasts? 5 minutes. Maybe 10 if they're being polite. This isn't a criticism of venture capitalists. They have a fiduciary responsibility to their investors to fund projects that can generate returns. That's how capitalism works, and it works well for innovations that can be monetized relatively quickly. But sending humans to Mars, that's not a business plan. That's a civilizational undertaking. The kind of project that requires the resources of entire nations and the willingness to invest in something whose primary returns might be scientific knowledge, technological capability, and national prestige rather than profit. Here's how I actually see Mars missions unfolding based on the historical pattern of every major space achievement. The United States or China or some international coalition decides, for geopolitical reasons, that we need to send humans to Mars. NASA, or its international equivalent, gets the mandate and the funding. They look around for the best rocket technology available, and Elon says, "I have exactly what you need," and rolls out his Mars-capable rocket. We end up riding SpaceX rockets to Mars. But it's a NASA mission funded by taxpayers and driven by national objectives. That's not a criticism. That's just how expensive, risky ventures into truly unexplored territory have always worked. And you know what? I'm delighted that SpaceX is developing the technology we'll need for that scenario. The announcement that they're planning to send uncrewed missions to Mars in the coming years, that's genuinely exciting because no one has ever sent a rocket to Mars that was designed to carry people. Even if those particular flights won't have crew aboard, that would be a legitimate advance into previously unexplored territory. Not just doing something NASA's been doing more efficiently, but doing something nobody's done before. I look forward to seeing how that unfolds. But let's be realistic about the challenges involved. Mars is not a quick trip to the space station. A minimum energy transfer orbit from Earth to Mars takes about 9 months. If you want to bring people back, and you definitely want to bring them back unless they've signed up for a one-way colonization mission, you have to wait for the planets to align properly again for the return journey. A complete round trip takes several years. Several years of keeping human beings alive in one of the most hostile environments imaginable, with no possibility of rescue or resupply from Earth, no backup systems that aren't already aboard the spacecraft, and no margin for error that could result in the deaths of the entire crew. That's the kind of risk profile that governments accept for geopolitical objectives. It's not the kind of risk profile that private companies accept for return on investment. But here's where the story gets even more interesting. SpaceX's real breakthrough isn't in going places NASA has never been. It's in dramatically reducing the cost of going to places NASA has been going for decades. The engineering triumph of reusable rockets isn't just cool to watch. It represents a fundamental shift in the economics of space access. When you can land a rocket and use it again, instead of throwing it away after one flight, you transform space from an incredibly expensive frontier accessible only to governments into something that's merely expensive enough to be accessible to large corporations, research institutions, and eventually maybe even individuals. That's not a small achievement. That's potentially civilization changing, but it's civilization changing in a different way than pushing into unexplored territory. It's about democratizing access to a frontier we've already reached rather than extending that frontier to places we've never been. And honestly, that might be more important in the long run. The Apollo program proved we could get to the moon, but it was so expensive we couldn't sustain it. If SpaceX's innovations make space access cheap enough that we can sustain permanent human presence beyond Earth, that might matter more than any single dramatic mission to Mars. This brings me to something that really bothers me about how these discussions get framed in the media. When I point out that private companies are doing things governments have been doing for decades, just doing them more efficiently somehow, that gets twisted into clickbait headlines says SpaceX hasn't accomplished anything. That's not what I said. That's not what I think. And frankly, it's the kind of clickbait headline that makes productive conversations about space policy almost impossible. What SpaceX has accomplished is genuinely impressive. They've revolutionized rocket engineering, dramatically reduced launch costs, and proven that private companies can be reliable partners for government space agencies. Those are significant achievements that deserve recognition. But there's a difference between recognizing impressive engineering and pretending that impressive engineering is the same thing as pioneering entirely new frontiers. When we blur that distinction, we lose sight of what it actually takes to push human civilization into genuinely unexplored territory. The current American program to return to the moon, Artemis, shows you how this actually works when you're serious about going somewhere challenging. 3 planned missions. First, an uncrewed flight around the moon and back, which has already been completed successfully. Second, a crewed mission to lunar orbit but not landing. Third, a crewed mission that actually lands on the lunar surface. Notice the incremental approach. Each mission builds on the previous one, reducing risk and testing systems before committing human lives to the most dangerous phases of the mission. That's exactly how the original Apollo program worked. Each Apollo mission was incrementally more ambitious than the previous one. That's how you explore space safely when human lives are on the line. You don't just strap people to your biggest rocket and hope for the best. You test, you verify, you build confidence step by step. And here's what I find fascinating about SpaceX's announced Mars plans. They're following exactly the same approach. Start with uncrewed missions to work out the bugs in the system before putting human lives at risk. That's smart. That's how exploration should be done. But let's talk about what those Mars missions would actually involve, because I think most people underestimate the sheer audacity of what we're contemplating. Mars is not just far away. It's far away in a way that fundamentally changes every aspect of how you think about human space travel. When something goes wrong on the International Space Station, we can get people home in a few hours. When something goes wrong on a moon mission, we can get people home in a few days. When something goes wrong on Mars, you're looking at years before the next launch window even opens. That changes everything. Every system has to work perfectly for years, not hours or days. Every component has to be designed with incredible redundancy because there are no spare parts coming from Earth. Every contingency has to be planned for because there's no possibility of rescue. The psychological challenges might be even more daunting than the technical ones. These aren't test pilots on a few-day mission where they can see Earth through the window and know that home is just over the horizon. These are people who will watch Earth become just another point of light in the sky and then disappear entirely as they travel deeper into the solar system than any human has ever gone. They'll spend months in a cramped spacecraft knowing that if anything goes seriously wrong, they're going to die billions of miles from everyone they've ever known. And then if they survive the journey, they have to live and work on a planet that's trying to kill them every moment of every day. Mars has an atmosphere, but it's mostly carbon dioxide at less than 1% of Earth's atmospheric pressure. Step outside without a pressure suit, and your blood will literally boil. The soil contains toxic perchlorates that would poison you if you tried to grow food in it. The radiation environment is so harsh that a Mars mission would expose astronauts to their entire career dose of radiation in a single trip, and that's assuming everything goes right. Now imagine trying to sell that mission to venture capitalists. We want to send people to a place where the environment is actively hostile to human life, where they'll be exposed to life-threatening radiation levels, where any significant equipment failure means certain death, and where we can't bring them home for several years. Also, it's going to cost more than most countries' entire GDP. What's the business case? Well, we might learn some interesting geology. That's not a venture capital pitch. That's a national space program. But here's where I want to give credit where credit is due, because this is important. What SpaceX is doing with their Mars mission development could absolutely represent the beginning of a genuine space frontier expansion if it leads to capabilities that no one has demonstrated before. Sending a rocket to Mars that's designed to carry people, even if the first missions are uncrewed, would be breaking new ground. Nobody's done that. NASA's Mars rovers and landers are marvels of engineering, but they're not human-rated systems. They're not designed with the life support, radiation shielding, and return capability that you'd need for people. If SpaceX can demonstrate that they can send a human-capable spacecraft to Mars, land it safely, and potentially bring it back, that would represent a genuine advance in human space capabilities. That would be pushing the frontier forward, not just making existing capabilities cheaper. And that's exactly the kind of achievement that could change the equation for future Mars missions. If the technology exists and has been proven, then when the United States or China or whoever decides for geopolitical reasons that we need to put humans on Mars, will have the tools to do it. The historical pattern is clear. Governments drive the initial push into expensive, risky territory, but they often rely on technologies and capabilities developed by private industry. The Apollo program used rockets built by private contractors. The Manhattan Project relied on materials and components produced by private companies. Government vision and funding, private sector execution and innovation. That's how major civilizational projects typically work. So when I look at SpaceX Mars ambitions, I see them potentially playing a crucial role in humanity's expansion beyond Earth. But I see that role as developing the technological capabilities that governments will eventually use for geopolitically motivated missions, not as replacing government space programs entirely. And honestly, that's probably the best possible outcome. Government space agencies like NASA bring decades of experience in human spaceflight safety, mission planning, and risk management. Private companies like SpaceX bring engineering innovation, cost efficiency, and the ability to move quickly when they're not constrained by government bureaucracy. A Mars mission that combines NASA's expertise in keeping humans alive in space with SpaceX innovations in rocket technology and cost reduction. That could be the combination that finally makes sustainable human presence on Mars a reality. But let's not pretend that this represents some fundamental shift where private enterprise is now leading human space exploration. What it represents is the natural evolution of how major technological challenges get solved. Governments fund the initial research and take the biggest risks. Private companies figure out how to do it better and cheaper, and eventually you get capabilities that neither could have achieved alone. The real test of whether we're truly pushing the space frontier forward isn't whether private companies can do things NASA has been doing more efficiently. The real test is whether we can do things that nobody has done before. Things like establishing permanent human settlements on other worlds, developing closed-loop life support systems that can operate independently for years, or figuring out how to produce fuel and other necessities using local resources on Mars. Those are the challenges that will determine whether humanity becomes a truly space-faring civilization, or whether we remain essentially Earth-bound with occasional trips to low Earth orbit. And here's what gives me hope. I see both government space agencies and private companies working on exactly those kinds of challenges. NASA is developing technologies for extracting oxygen from the Martian atmosphere and producing rocket fuel from local materials. SpaceX is working on reusable spacecraft that could make regular travel between Earth and Mars economically feasible. These aren't competing visions of human space exploration. They're complementary approaches to solving different aspects of the same enormous challenge. And that suggests to me that we might actually be approaching a point where sustainable human presence beyond Earth becomes possible. Not because private enterprise is replacing government space programs, and not because government space programs are rendering private innovation irrelevant, but because both are contributing essential capabilities to what is fundamentally a civilizational project that's bigger than any single company or even any single nation. That's the cosmic perspective on human space exploration. It's not about individual achievements or corporate success stories or national prestige. It's about our species taking its first tentative steps toward becoming something more than a single-planet civilization. Whether those steps happen on government rockets or private rockets, whether they're motivated by scientific curiosity or geopolitical competition, or eventually even profit, what matters is that they happen. What matters is that we develop the capabilities, the knowledge, and the experience to ensure that human consciousness and human culture can survive and thrive beyond the single world that gave us birth. And from that perspective, every genuine advance in space capability, whether it comes from NASA or SpaceX or anyone else, is worth celebrating because it brings us closer to a future where the long-term survival of human civilization doesn't depend on the continued habitability of one small planet orbiting one ordinary star in one typical galaxy among billions. That's not just an engineering challenge or a business opportunity or a geopolitical objective. That's the most important thing our species could possibly be working on. Ensuring that the universe's capacity for self-awareness, for wonder, for creativity and love and scientific understanding doesn't depend on the continued existence of Earth. We are the cosmos becoming conscious of itself, and our expansion beyond Earth isn't just exploration. It's the universe's insurance policy against the possibility that consciousness could be snuffed out by a single catastrophic event on a single world. That's why this matters. That's why I get excited about genuine advances in space capability, regardless of who achieves them. And that's why I think it's important to be precise about what constitutes a genuine advance versus what constitutes doing the same things we've been doing, just better. Both matter, both contribute to the long-term project of human survival and expansion beyond Earth. But understanding the difference helps us appreciate what we've accomplished, what we still need to accomplish, and how we're going to get there. The more I think about this whole dynamic between government space programs and private space companies, the more I realize we're witnessing something unprecedented in the history of human exploration. Never before have we had private entities with the technological capability and financial resources to genuinely contribute to pushing the boundaries of where humans can go and what we can accomplish in the most hostile environments imaginable. When European explorers were crossing the Atlantic in the 15th and 16th centuries, private companies eventually took over trade routes and colonization efforts, but only after governments had proven the routes existed and were profitable. When American pioneers were pushing westward across the continent, private enterprise followed government surveys and military protection. But space is different. The initial government investment has been so massive, and the technological barriers so high that we're seeing private companies developing capabilities that genuinely complement and sometimes exceed what government agencies can do with traditional procurement methods and bureaucratic processes. This creates possibilities that didn't exist in previous eras of human exploration. When NASA needs a particular capability, they don't just have to build it from scratch through a decade-long government contracting process. They can potentially partner with companies that have already been developing those capabilities for their own commercial reasons. Take asteroid mining, for example. NASA has sent robotic missions to asteroids for scientific purposes, but they're not in the business of developing commercial asteroid extraction technologies. Private companies like Planetary Resources and Deep Space Industries have been working on exactly those technologies because they see the potential for enormous profits in space-based resources. If and when NASA decides we need asteroid-derived materials for Mars mission construction or for building large-scale space habitats or for any other deep space exploration goal, they might be able to leverage technologies and capabilities that private companies develop for completely different reasons. This kind of technological convergence between commercial and scientific objectives could accelerate human space capabilities in ways that pure government programs or pure private venture never could achieve independently. But this is crucial. None of this changes the fundamental economics of pushing into genuinely unexplored, high-risk territory. Private companies are brilliant at improving existing capabilities and finding commercial applications for proven technologies. They're much less willing to fund the kind of basic research and initial risk-taking that opens entirely new frontiers. The James Webb Space Telescope cost $10 billion over more than 2 decades of development. It had no clear commercial application, enormous technical risks, and required pushing multiple technologies far beyond their previous limits simultaneously. No private company would have funded that project because there was no conceivable return on investment. But the scientific knowledge we're gaining from Webb is already informing our understanding of planetary formation, stellar evolution, and the conditions necessary for life throughout the universe. That knowledge will eventually influence how we design interstellar missions, how we search for habitable exoplanets, and how we think about humanity's long-term future among the stars. Government-funded basic research creates the foundation of knowledge that private companies eventually build upon. Private companies create the technological innovations and cost efficiencies that make government-funded exploration programs more ambitious and effective. It's a symbiotic relationship, not a competitive one. And honestly, that's exactly what we need for the challenges ahead. Because the next phase of human space exploration, the phase that takes us beyond the Earth-Moon system and establishes sustainable human presence on other worlds, is going to require capabilities and resources that dwarf anything we've attempted so far. Consider what it would actually take to establish a self-sustaining human colony on Mars. You're not just talking about getting people there and keeping them alive for a few years. You're talking about creating a complete industrial infrastructure on a world that has no breathable atmosphere, no liquid water on the surface, no magnetic field to protect against radiation, and no ecosystem to provide food, medicine, or other biological resources. Every tool, every piece of equipment, every electronic component, every medical supply would either have to be shipped from Earth at enormous cost or manufactured locally using Martian materials. That means developing mining operations, manufacturing facilities, chemical processing plants, power generation systems, closed-loop life support systems, and agricultural systems that can all operate reliably in conditions unlike anything on Earth. The initial investment required for that kind of infrastructure would make the Apollo program look like a small research project. We're talking about the economic equivalent of building entire cities from scratch, except those cities are on a planet where everything is designed to kill you, and the nearest source of help is months or years away, even under the best circumstances. That's not a business plan any private company could reasonably pursue. Because the upfront costs are enormous, the technical risks are unprecedented, and the timeline for any possible return on investment is measured in decades or centuries, not quarters or years. But it's exactly the kind of civilizational project that governments can undertake when they're motivated by long-term strategic objectives rather than short-term profit calculations. And it's exactly the kind of project where partnerships with innovative private companies could make the difference between success and failure. Imagine a Mars colonization program where NASA provides the overall mission architecture, risk management, and life support expertise developed over decades of human spaceflight experience. SpaceX provides the heavy lift launch capability and spacecraft systems optimized for regular Earth-Mars cargo runs. Other private companies contribute specialized technologies for in-situ resource utilization, closed-loop life support, radiation shielding, and local manufacturing. Each organization contributes what they do best, and the combined capability exceeds what any single entity could achieve working alone. Government provides the vision, the funding, and the willingness to accept enormous risks for civilizational rather than commercial objectives. Private companies provide the innovation, the efficiency, and the ability to iterate and improve systems rapidly based on performance rather than bureaucratic processes. That's not private enterprise replacing government space programs. And it's not government programs making private innovation irrelevant. It's the evolution of human space exploration into something more sophisticated and capable than either approach could produce independently. And from the cosmic perspective, that evolution might be exactly what we need to become a truly space-faring species. The challenges of establishing human civilization beyond Earth are so enormous that they require the best capabilities that both government agencies and private companies can contribute. The universe doesn't care whether we solve those challenges through government programs or private enterprise or some hybrid approach. What matters is that we develop the technologies, the knowledge, and the organizational capabilities to ensure that human consciousness and human culture can survive and thrive beyond the single world that gave us birth. Because ultimately that's what this is all about. Not national prestige or corporate profits or individual achievement, but the continuation of the cosmic evolutionary process that created consciousness in the first place. We are the universe becoming aware of itself, and our expansion beyond Earth represents the next phase in that awareness becoming more robust, more distributed, more likely to survive whatever catastrophes might threaten any single world. That's the most cosmic perspective of all. We're not just exploring space, we're participating in the universe's ongoing project of understanding itself. And that project is too important to depend on the continued habitability of any single planet. No matter how beautiful and life-supporting that planet might be, the universe spent 13.8 billion years creating the conditions necessary for consciousness to emerge. It would be tragic beyond measure if that consciousness disappeared because we couldn't figure out how to establish ourselves beyond the single world where we happen to evolve. But it would be magnificent beyond imagination if we could use our brief moment of cosmic self-awareness to ensure that consciousness persists and flourishes throughout the universe, carrying with it everything we've learned about science and art and love and wonder during our time as Earth's dominant species. That's what's really at stake in these discussions about space exploration. Not corporate success or national prestige, or even individual human lives, but the continuation of the universe's capacity for self-standing. We are the cosmos becoming aware of itself, and our expansion beyond Earth is the cosmos working to ensure that its self-awareness survives whatever catastrophes might threaten any single world. That's the cosmic perspective on human space exploration, and it's why every genuine step forward matters regardless of who takes it or how they take it. We're all participants in the same extraordinary project, ensuring that the universe's capacity for wonder and understanding doesn't end with us.